Hi everyone, welcome back. A few videos ago we set up a database connection, but we didn't actually insert any data. There's not even any tables in here. And today's the day I want to change that. Now when working in a team there are probably multiple environments. There's a production environment, there's probably an acceptance or a test environment, and there's all these local environments of developers. And each of these environments probably has a database. And unlike with our code, our database doesn't live in version control. So we want to make sure that the database in all these environments is in sync. And there are actually multiple ways to achieve this, but today I want to look at database migrations. Laravel and also Symfony support migrations out of the box, but for those to work you need to have a Symfony or Laravel application. And that's not the case in our example project. And I think it actually makes sense to go over how these migrations work below the surface, because it's actually quite interesting. So that's what I want to do in this video. Now there's 2 points from which we could start here. There's the console command which we execute, and then there's the endpoint where there's actually migration code. And for now, because we left off with the console last time, I want to start off with a new command. So in here we have a list of commands. Right now there's only a clear cache command. And let's actually create a migrate command. Now to actually set up our command we need to extend commands from Symfony, because we're using the Symfony console commands. We need to mark it as a command, mark it as migrate, and then we need to fill in the execute method. And for now, I'll just return 0, means success, and then we register it in the kernel in our commands. So now if we execute console migrate, we don't get an error because it returns 0. And it's already time to think about where we're going to put our migrations, because then we can read them from here. And the migrations themselves are not going to be reused a lot. And they're more a kind of asset than actually a piece of code, because we're only ever going to execute them once for each environment. So what I usually choose for, and what other frameworks do as well, is to add a folder outside of the source folder and call it migration or database. For now, let's keep it as a migration. And sometimes we need to make sure that these migrations are run in a certain order. So in some migrations, we might be modifying tables we created in earlier migration, or there might also be multiple people adding migrations at the same time, because we are working in a team. So the way these are usually named is starting with a date with underscore. So it's 2024, October 10th. And then I usually add a timestamp as well. Let's do 12 o'clock. And let's give it a name so other people can see from the file name what's happening in here. So we're adding the user table. Now, as these classes are only ever used once per environment, it doesn't make sense to add them to a namespace and to add them to the autoloader. So what we can do instead is return a new anonymous class. And in here we can do the actual migration. And usually there's an up and a down method. I'll just add an up for now. And then in our migrate command or in our migration handler, we can actually require this file. And then if we require it, we get back this anonymous class. Now you saw me add this up method, and there's usually also a down method. And basically these are mirror images. So if we add a table in our up method, we remove it in our down method. And this is so that whenever something happens, we can roll back a migration. So if there was a migration that didn't make sense, we can actually revert it. But for now, let's not make things too complex, and let's only focus on this up method, because that's the most important part here. Now in a previous video, we already set up Doctrine DBEL as an abstraction layer to connect to our database, and we can actually use that to manage our schema. So in the package, there's an abstract schema manager. Just use schema manager, and we can actually execute several things on here. We can alter schemas, alter tables, we can do a whole bunch of things on here. But there are some things we can actually not do on there, so we'll also add a connection as an argument here. And now we have everything we need to write our migrations. But right now there's no way to check if our migration class actually follows the same pattern where there's an up method with these two arguments. So let's copy this signature and let's actually add a interface for this. We already have a database folder, but let's add a migration class in here, which is actually an interface. And then we can add the signature here. So these. And then in our migration, we can actually mark this as implements migration. And let's actually set up this user table. We have a new table. And with the schema manager, we do create table of this user table. And let's add some columns. We have a UUID, type string, with a length of 36. And we have two more columns. We have an email. I think the length can be 320. And we have a password hash. B25. And then we have some unique constraints. Add unique constraints. So we have the email column needs to be unique. And to be unique. And of course, we need a name here, which is user. And now that we know what we get back from these migration files, we can actually start implementing this. And we're going to iterate over all the migration files. So you can add the for each. But we need to somehow get these migration files. And let's use the file system iterator for this. So we have to pass it a string to the directory. Just 3 folders up, and then our migration folder. And let's actually test if we get back our migration files. So we do a console migrate. And then we get back our add user table migration. And we prefixed our migrations with this date timestamp. But the fact that our files are sorted in our migration folder in our file viewer here doesn't mean that we also get them back sorted from our file system iterator. So let's actually manually sort these files. And usort sorts in place, so we don't need to reassign this. And then we pass it to a static function. And we get 2 parameters. We get SPL file info A and SPL file info B. And then we basically return A, get base name, compared to the spaceship operator of B, get base name. And let's also import this. But right now we get a file system iterator and it's not an array. So we need to actually do iterator to array on this file system iterator. And now that we have a sorted list of migrations, we can actually require the migration. So we do a require once of the migration file, get path name, and then if the migration not an instance of migration, we throw a new invalid argument exception. A nice message. Is not a migration, and we pass the migration file path name. So now here we have valid migrations. And let's actually test this before we move on, because I see an issue here. This should be false. Now the next thing we could do is just execute the migrations now. But we don't want to check in each migration if itself has already been executed. So we want to make sure that if a certain migration we have here is already been executed, we skip it, and otherwise we actually execute it. We have a migration up. But to check if a migration has been executed, we don't have anything right now. And it makes sense to actually do this in a database as well, to create a table migrations and to keep track of the executed migrations in there. And now that we're past the file system iterator and the sorting of the files, we actually have a class that implements this migration interface. And that's already in here. And seeing how complex things are getting, I think it makes sense now to actually split up what we're doing here into a migration handler. So let's create a class here. And let's start from the migrate command to see what we need here. And as we don't have dependency injection in the commands yet, let's just create a migration handler from the kernel get container and then get the migration handler from there. And then basically what we want to do is if the migration handler has executed migration, this specific migration, then we continue. And otherwise, we let the migration handler execute the migration. And it doesn't recognize this currently, so let's just mark this as the migration handler and fix this later. And then you'll see that these methods are not here. So let's create them. And then we can continue from here. Now, if we're migrating a completely empty database, we first need to check if our migration table even exists. So we can ask the schema manager that, but for that we need to have a schema manager. So we do a private read-only schema manager. And then we ask this schema manager table exist migration. If not, we create migration table. And after that, we can continue. And we need to do the same with the execute migration. Just to make sure that if we ever call this in a different order, things will work the same. So let's fill this create migration table method. So the migration table is new table, migration. We add a column called name, string, and has a length 255. And then we have a migration column at date time. And then we can call this schema manager at create table. And void. And after we've made sure that our table exists or we have created it, we can call our repository and check if our migration with the same name already exists in the database. And for that we use repositories. So let's create a migration repository. And then as usual in here we have a constructor argument of our connection. And then let's add it as a dependency here as well. So we have a private read-only migration repository. And then in here, we can now return migration repository has been executed of this specific migration. And then we can add this method on here. And now to actually retrieve this from the database, we do this connection, create query builder, select m.name from migration alias m, where name equals question mark. Set parameters. First one should be migration. We don't have name, so we can do of the migration. File name. And then we check with fetch 1. If that's false, it hasn't been executed. If true, it has. And let's add the missing return type. And now we're writing repository queries anyway. Let's also add a mark as executed for this migration. Don't return anything. And instead of the select the from the where, we do an insert migration table values of name add. We already have the name here, and our add is going to be formatted datetime immutable. And we format it with day, second. And instead of fetch 1, we execute statement. And now we can actually go back to our migration handler that has executed migration. Is finished, and then execute migration should still be completed. So if this has executed migration, should throw an exception. Migration already been executed. And otherwise, we want to call the up on the migration, and then in the repository, we want to mark the migration as executed. It expects a timestamp or datetime immutable here. For now, let's just do new datetime immutable, but preferably this would come from a clock somewhere. And then here we need the schema manager, and we already have that in this class, and we need the connection. Don't have that. Add it here as a structure argument. Can pass it here. So let's look at if we have filled all methods. So in our migration command, we skip all migrations that already have been executed, and then we execute them. I think we're ready to give this a test run. Let's do console migrate again. And yeah, we rely on the abstract schema manager, but we didn't add a provider for that. Schema provider. So we implement the service provider interface. We provide the abstract schema manager class. And then on our resolved set, add new abstract concrete, the identifier, and based on the existing connection from the container, we return schema manager. And then, of course, register this kernel, so schema manager provider class. And if we now execute the migrate command again, failing on the network get address, but that's because right now we're executing the command locally and not from within the container. We haven't configured this yet. Let's actually go to the container and execute it from here. Now it's complaining that database migration doesn't exist. This is also inverted. Doesn't exist, we need to create it. And that's finished. So let's see. We actually have our new tables here now, and we do. But as you might notice, this file path is now absolute, and that's not ideal. I took some shortcuts earlier, but yeah, let's fix this properly now. I retrieved the file name from the reflection class of the migration, but this should just be the migration name, or just the name here. And this should just be a string. We need to do the same here. Name. Name. And then here, only use the string as well. Here we need to pass the string. And then we need to do the same here. But here we actually need the migration. So we both name and the migration itself. We need to pass the name here. We can easily retrieve the name for the migration from the migration file here. You get base name with .php. You should get a nice clean name. Of course, we need both the name and the migration here. Git migration. So if we now open our database and drop both of these tables, we can restart. We can do console migrate again. And then if we refresh this, it should be a nice name. And if we now look at our user table, this is also set up, so our migrations work. And that's it for this video. Make sure to subscribe if you haven't, and I hopefully see you in the next one.